Our next unit deals with similarity. Let's say I have two figures that are congruent. We know what it means for two things to be congruent. But what if we change the size of one of the figures? Either make it bigger or smaller. These two figures are still similar even though they're not congruent. So maybe not everything measures exactly the same, but the angles are still preserved and the ratio of the corresponding sides are going to be congruent. Figures are similar if they have the same shape but not necessarily the same size. Although they could be the same size, but they don't have to be. Here's our formal definition. Polygons are similar if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. It's important to understand that the angles have to be congruent, but the side lengths don't, but they're proportional. I'll explain what that means in a few minutes. Let's look at an example. Here's two figures that look like they're the same shape, although obviously not the same size. Looking at the angles, we can see that angle B matches up with angle F. Those are congruent. Angle C with G, angle D with H, and angle A with E. So when you see the directions write a similarity statement, that's kind of like writing a congruent statement. But instead of using the congruent symbol, we're using a similarity symbol. So we would say that polygon ABCD is similar to polygon EFGH. Now it's important that we match up the corresponding letters. It didn't matter that I started with A for my first polygon. I could have written the first polygon almost any way I like. I could start with any letter and either go clockwise or counterclockwise. So for example, C, B, A, D. But then I have to make sure that I match it up in the right order with the other polygon. So since I started with C, that matches up with G. So there's several ways that I can write the similarity statement, and it doesn't matter which way you like to start it, as long as the corresponding vertices match up. Another thing you should be able to do is list all the congruent angles and then match up all the corresponding sides. So all those angles are congruent. Now we have to deal with the sides. The order that I wrote those doesn't really matter, each of the fractions. It's just important to realize that side AB matches up with side EF. So the ratio of those two sides is going to be equal to the ratio of any other two corresponding sides. Let's look at a few more examples. Are these two polygons similar? If so, we have to write a similarity statement and then the similarity ratio. Well, let's first decide, are the polygons similar? So the first thing you have to do is look at all the angles. Are all the corresponding angles congruent? And the answer to that is yes. Angle W is congruent to angle P, angle X with angle Q, angle Y and R, angle Z and S. So now the only other thing we have to check is that the ratio of the corresponding sides are the same. So let's pick any side from the polygon on the left. Let's say I use 6 from X to Y. That matches up with the 4 in the other polygon. So I need to see if that fraction is equal to any of the other matching corresponding sides. Now, depending on how good your fraction work is, you need to decide, are these fractions all equal? Are they equivalent? I think the easiest way for you to check is to use your calculator and just divide. So type in 6 divided by 4 and see what you get. You'll get 1.5 on your calculator. Now do 9 divided by 6. You also get 1.5. 12 divided by 8. And 15 divided by 10. All of these must be equal. If 3 of them are equal and 1 is not, that's not good enough. But in order for these polygons to be similar, all 4 of those have to match, and they do. So the answer to the first question, are the polygons similar, is yes. So the next thing we have to do is write a similarity statement, as we did in the last example. So we'll start with the polygon on the left and choose any letter to start with. I'll start with X. And then match those up, Q, R, S, and P. So there's our similarity statement. Now the similarity ratio, that's simply any one of your fractions reduced. So for example, if I pick 12 over 8, I need to reduce that down. I could divide a 4 out of the numerator and denominator. So my ratio is 3 to 2. Sometimes you'll see this written with a colon instead of a fraction. And either way is fine. Let's look at another one. Are these polygons similar? Well, of course, all the angles match. They're all 90 degrees. So we need to check, do the corresponding sides give you the same ratio? So let's look at the one on the left. If I start with 15, now which one am I going to match that up with? Is it going to match up with the 3 or the 10? Well, in the left triangle, 15 is the bigger side. So if this is going to work, I'm going to want to match it up with the bigger side in the other triangle. And does that equal the other two, 8 over 3? The answer to this one is no. If you divide them on your calculator and look at the decimals, They are obviously not equal. So therefore, these polygons are not similar. So even though they're both rectangles, they're not similar. Look at one more example. How about these polygons? Now the first thing you want to do before you start looking at the ratio of the sides is double check your angles. You can see the one on the left, we know 30 degrees and 100 degrees, so we can figure out the other angle. That gives you a 50-degree angle. You can also figure out the missing angle in the other triangle. And since these two triangles do not have matching angles, we don't even have to check the sides. The polygons are not similar.